This is Steve Koster with Espresso Engineering. We're here in Denver at the EMC Symposium and get a chance to catch up with Don Heirman. Don, how you doing?
Oh, I'm just doing fine.
That's great.
It's Thursday.
Thursday, last day, but you've picked up a lot of interesting information for us this week, haven't you?
Yeah, I thought what might be useful is that there's a lot of standards activity, not only in the EMC Society, but in the International Electrotechnical Commission and even C63. So maybe what I can do is give a kind of an overview, starting with the society standards.
That would be great.
And then, the hot topics, more or less.
Right.
And if anyone's interested further, they can, of course, contact me and we'll pursue it. So let's start off with the IEEE standards that I think are of interest. One of the ones that we're doing right now is on standard 299.1, which is a shielding effectiveness standard, and down to dimensions of tenth of a meter up to 2 meters, in other words, smaller boxes, if you will. That is about to be published, which is interesting. And there was a sequence. 299 was the larger semi-anechoic chamber type thing, and somebody said, well, why don't we go way down to a printed wiring board level? Wouldn't that be interesting? The problem there is you can't put a source in and measure the difference with or without it. So it may be an entirely different approach, maybe even using reverberation techniques. So 299 is I think, of interest to your viewers here. The other one, there's 2 or 3 others, so let's just go through them. Standard 473 on site surveys is sort of being restarted again. And the idea of that is, even if you take an antenna, walk around the exhibit hall here, how would you know to characterize all the RF that's here and what's coming in from the outside?
Right. So
this is a standard that updates that technique, which has been around a while. For example, you might take an antenna and go close to a air conditioning metal duct. You get a totally different answer. And in fact, in some cases, we've seen AM radio having actually an amplification while you're in here because of the way in which it comes in the slots, etc. So that is a standard that's we're moving forward with. Then we have a couple of other interesting ones. 1642 is intentional EMI to computing devices, and obviously there's some cybersecurity implication there. Imagine if, in fact, you can go on the internet right now and get yourself a used amplifier, make yourself an antenna, put it in literally a briefcase, that's small, it's a little heavy, and go up to an ATM machine and cause problems. And of course, if you carry that on and going into an office and cause problems. So this particular standard was meant to address how do you further immunize, if you will, that device, and what to expect from what we call intentional EMI.
Right.
And there's a lot of interest in that, not only in our country but abroad. Next one I want to just say briefly about is 1688. This is a sub-assembly test of whether it's of its emission and immunity potential. And if you can get a sense of what it is at subassembly, you have a better chance of knowing what it might be when you put it all together. We've been doing this, for decades, trying to come up with some characterizations, and this is about ready to go to vote, and I expect we're going to get significant comments back on that. And maybe it'll pass, maybe it won't, but I think it's worth bringing it to attention. And another one is probe calibration. You use it in the 61004-3 test. We have a standard 1309 that is the calibration technique that many of the Cal labs are using, and this now has gone through its usual improvements and amendments, and it's about ready to be published. And when I say being published, we're talking about, by the time it goes through the editing process, you're talking 2, 3, 4 months. But the ones I'm thinking about here, hopefully by the end of the year. The last one is we have 2 computational electromagnetic standards, and they met this week here at the symposium, and they're going to the next round of how to use it. And the idea of the computational now is you get the computations, maybe it will complement what you do in an actual measurement.
Right.
And it'd be nice if it's close enough, then you can do it mathematically, do some manipulations, classical stuff. So that's really all I want to bring up in the EMC Society. We have about 16 standards, and I just highlighted a few that are hot topics right now. I'd like to shift gears a little bit, go over to the IEC, International Electrotechnical Commission. And the ones that we're mainly interested in are from two committees in the IEC, namely CISPR, which is International Special Committee on Radio Interference, and TC77, which is EMC. One of the things that I'll just focus on a couple because I can't, we're talking about dozens and dozens of them. Let's take CISPR, for example. Last year, January of last year, they published a new standard called CISPR 32, which is on multimedia emission testing. It was to replace two standards. One, CISPR 22, which is information technology equipment, and the second one is CISPR 13 on broadcast receivers. Well, okay, it was accepted, and just a simple question is, if you're doing a computer test, what do you put on the screen? Scrolling H's or whatever. If you're doing a television test, receiver test, you put color bars.
Right.
So which one won?
Which one wins? It's good to have a standard to let us know that.
Yeah, there's like 5 different priority checks, and one of the ones that's becoming popular, if I split the screen, half color bar and half scrolling H's, is that reasonably okay for the near worst case for both types of equipment? And there was a paper published by Dave Arnett last year, and that's being discussed.
Right.
But right now, you can start off with color bars, you work your way down to scrolling H's and other, and it's up to what you put in the test report. Clearly, if you mark it more of a TV set, you might want to do the color bars.
Right.
Yeah. So that has been published and really is a little different in that you test the ports on your box, whether it's your laptop computer, you have a USB port, you have a D connector, you have all this, as opposed to 22, where you just simply tested the whole arrangement, and you only had to populate a couple things on the ports.
Right.
Well, you can see now if you have 10 different ports, you got more testing to do. However, it's then technology neutral. If it's a radio port, you test the radio port, no matter what it is that has a radio in it. So from that perspective, it was meant to be long term. The next question you might ask, well, when is 22 and 13 going out of existence? Well, they now officially have put on the website that in March of 2017, you'll no longer be able to buy those standards. Now, you can always buy it, by making a special order, but it won't be on the IEC shop.
The IEC shop will.
So now the question is, will the European Union accept 32? They have converted it into EN 55032, but as of this moment, we're talking first week in August, it's not been published in the official register. So therefore nothing can happen to it. My guess is, and pretty educated, that they'll wait for a 3-year transition period.
Right.
And they'll withdraw the 22, EN 55022 and 013. So stay tuned. But I would suggest to laboratories out there, you ought to start trying this new test technique and seeing, because your customers are going to start asking questions. Why not get a head start on it?
Exactly.
From going to more basic standards, I only have 2 for this discussion. The new antenna calibration standard is CISPR 16-1-6. It's not published yet. It's been 20 years trying to publish the darn thing. And that has some of the concepts of C63.5 on it, but it doesn't, it's just referencing .5. It doesn't embed it all. And the idea of that standard is there's 4 or 5 ways of calibrating an antenna, and the only difference is the uncertainty of each of those methods. So if you want the smallest uncertainty, you got to do a very much more elaborate test calibration. If you're willing to get by with the casual 1 to 2 dB, that's something different. Well, okay, someone has to then state that, use a test that, for example, have to say, I'm going to use this version, or I'm going to use C63.5, whatever is the case. And that's the uncertainty. You plug it into your uncertainty formula. The only other one I would bring up is currently there's a hot topic between what do you do to measure interference and immunity in the range 2 kilohertz to 150 kilohertz. We don't have test methods in the emission side.
Right.
So the question is, and the reason why this came up, TC13, IEC TC13, which are the meter people, they are concerned about what TC22 is doing, which are those that handle the power supplies. Because you put a bunch of power supplies that you're going to disrupt in that frequency range. They believe the metrology. And now you raise that level to smart grid, it's even worse, because obviously you want smart grid to succeed where it can. So this is a very active subject. The IEC at the advisory committee on EMC has come up with an interim solution with the principals, and that says you got to wait until 2014 or 2015 to get this compatibility level. Well, we can't wait that long. So there are some recommended design levels, and we agreed to that. And if but we also put a caveat. The caveat is, if things change, be aware, Mr. Manufacturer, and that's all we can do.
That's right.
So to end my little chat here with Steve, I'd like to talk a little bit about C63 standards. A couple. C63.4, which is the one for measuring emissions conducted and radiated, that's about to go to its last ballot next week. And because we've had 3 successful ballots, but every time they come up with some things we really should consider, and we keep adding in, but you got to stop.
At some point.
And this is the stop point, because I only have so much life left in me, and I want to get it out. I expect that we have pretty much covered the negative comments, and my expectation is that by the end of the year that will be out. C63.10 on measuring transmitters, which is that information was pulled out of .4 and put in the .10. The second edition has been approved, and that's up for publication, and I expect by the end of the year that will be published. And that included all of the test techniques for new technology from the FCC that was not in the .10 original version, and there's an agreement because they're all participating in that. Just a couple others. C63.23 is the measurement uncertainty document that's to be used in all C63 standards. The interesting part about this, most of this measurement uncertainty is based on type B, which is you get data and you look at the tolerance and where it's distributed. In this document, we're focusing on type A, which is statistical techniques, repeat measurements. For example, and some it may not be repeat. Let's say you have an antenna calibration for 5 years.
Right.
You've done it 5 times. So you look at the standard deviation of that, and guess what? That's what you plug into the formula without having to go back and do 5 repeat of the calibration. So there's some pluses to that. And also, when you do that test, everything in the instrumentation chain is taken care of. Boom, like that. Cables, mismatch, uncertainty of the receiver, spectrum analyzer you use, boom, it's all there. So that's a very positive, and we had a workshop on that over the weekend here in Denver, and we had a good turnout for that.
And when is that going to be published?
It's published March of this year.
March. Okay.
March of this year. But it's the first time it got public visibility.
Right.
So I'm glad that happened. I guess really the only other one I mentioned, the C63 covers unlicensed transmitters. C63.26, which is next, covers the licensed stuff. And that is probably into next year, but it's really very hot at the moment. And by the way, we're talking about working groups where 50 people show up, as opposed to 4 or 5 casual observers. And by the way, all of these are also Canadian participation.
Right.
So this is going to be a North America type activity, which is great. I think the rest of it, the only one I would mention it will close. Will close. is we have C63.27 on wireless coexistence. For example, at a hospital, we have everything. The instrumentation is covered by wireless connection. Right. Well, you have 50 of them. How do you assure that there's not crosstalk? And that's the main scheme for that. So to kind of summarize everything, we have a lot of stuff going on in EMC standardization, both in our society and internationally, and of course nationally with the ANSI work. And the last thing I always will say is, if you want to get involved and you have expertise, just get in touch with me and we'll get you on a committee.
Get you on a committee somewhere, absolutely.
Since I'm on 20 of them, you might as well be on 20 of them.
Exactly.
So I think that's it, Steve.
Great, thank you for stopping by. I mean, you're always such a wealth of information on all the new standards and everything that's up and coming. So this is Steve Koster with Espresso Engineering saying, see you later.
Au revoir.